So we're just going to be looking at this 2016 paper, right? I was looking at the paper I downloaded and I wrote out all the answers for them and then put in a compilation. But it's a unit 2 one I have, not the unit 1 one. Ah boy. Alright, okay, so let's look at this. Which of the following types of radiation is most likely to be measured by the Geiger counter? What does Geiger measure?
Sorry, repeat that, sir.
Sorry about that. You can see the screen now. So what is measured by the Geiger counter? We need to we're gonna go much faster, you know. So the Geiger counter?
It would be A, because it measures radioactive phosphorus.
So it'd be beta waves, right? Beta, right? So it's gonna be beta waves that it really does. Go there. Element P is
B, sodium.
Wonderful, and then this would be
A.
okay, right? And then here ammonia has the highest boiling point because
C.
B.
Okay, wait, hold on. For C, right? Are we saying that these other halides don't have hydrogen bonding?
Nope.
No. Are you saying no that they don't have hydrogen bonding? Or that's not what you're saying?
They have hydrogen bonding, yes.
Alright. So I think C would basically say that okay. Ammonia has highest boiling point because it has hydrogen bonding. But like the others have hydrogen bonding, so right? I think it's because there's more of the van der Waals forces between
Yes,
the
sir.
ammonia. Yellow metal. It's a type of alloy used to make ornaments, contains 60% copper and 40% zinc. How many moles of zinc atoms are there in 260 grams of this alloy? Right, so we have 60% of wait, zinc we're looking for? Oh, that's copper, so it should be 40%. My bad. What is 40% of 260? So the mass of the thing is 260, you know, and 40% of it is zinc. Alright, so go ahead. What is 40% of 260? You guys can't possibly take too long to do that, so you should be fine.
104.
Okay. So, 104. That doesn't sound okay. I guess it doesn't matter if it doesn't sound familiar. Alright, so 104. Alright, so it's gonna be equal to 104. And we're saying here that we're gonna take the mass of zinc that we have, right? That would be what, 6.3 something? 65.3 something. So let's just use 65, I guess. So how many moles would be in that? So if 1 mole
1.6.
okay, 1.6, right? So 1 mole give us 65. So how many mole give us 104? B 1.6. Alright. The bond angle of water is alright, no so oh, A. Alright, wonderful. Which of the following statements is true about 5 dm cube of hydrogen and 5 dm cube of oxygen at 0 degrees Celsius at 101 kPa? They put us the same number of particles, right, or molecules, right? That is Avogadro's law, right? Here we're looking at this. The maximum mass of lead oxide which can be obtained from 13.23 grams of lead nitrate is. What is the answer for this? What's the answer? Hello? What do you guys suggest as the answer?
Sir, is it B?
Is it? I'm not sure. Is it B? B seems a little bit off, but okay. You guys know what to do, by the way. You guys know what to do, right? Okay, nobody knows what to do either. Alright. So we're saying that the molar volume of gas, the RTP, is that. Okay, we already have that information. The mass of lead oxide, which can be obtained from that amount of grams of lead nitrate, right? We're looking at what that is. So when it is heated, there are 2 moles of lead oxide that comes from lead nitrate. We're looking at 13.23 grams. How would we find this? Come on, somebody step up, please. How do we find that? I'll ask if somebody can step up and answer this. Oh, we're looking at the question, and it's taking a bit long. Go ahead.
Sir, I'm lost in the question, sir.
You're not seeing the question? Or
No, I'm lost in it.
Oh, okay. Alright. Can anybody else assist? I want to see if one of you guys have the way or the method to complete this. I already did it before, but I want to see if you guys have the method of completing this. My law paper. Okay, you guys' answer. So nobody. Okay, let me see something. Let me look in the chats. Rayon, you have nothing to say about this? Renee? You guys don't know how to approach this? Marcia, you don't have any idea?
Sir, I guess you would probably multiply the maximum mass by 2. I'm not sure what to do after that.
The maximum mass of lead by 2. We're saying that it's a 1-to-1 ratio, and we're saying that the maximum mass, right, of lead oxide which can be obtained is 13.23 grams, right? Well, we're looking at what can be obtained from the maximum mass of 13.23 grams of lead nitrate, right? And we're saying that generally, right, we're looking at the mole ratio and saying that the number of moles of lead nitrate, right, should be in a 1-to-1 ratio with the number of moles of lead oxide. So looking at the mass of lead oxide that can evolve from 13.23 grams of lead nitrate. What is the number of moles containing within 13.23 grams of lead nitrate? Could somebody tell me that? Moles is equal to mass over molar mass. The mass is 13.23. Right? What is the number of, well, what is the molecular mass of lead nitrate? Molecular mass of lead nitrate? Give me a second.
Let me see. 331.
331. Wonderful. 331.22. Right, so 331.22. Right, that should give us what? Okay, what is the answer?
0.0399.
0.0399. 0.0399. Alright, so you're saying that's the number of moles that we have there. Right? Is that correct? So that's the maximum number of moles of lead oxide that can be obtained from that. Right? So the lead oxide from lead nitrate, we'll notice that there's going to be a 2 to 2, well, 2 to 2 ratio. Right? So can anybody try to figure out what would be the answer here? Alright, I'm taking it from this approach to allow you guys to see that, alright, that this may be a bit off. So notice that this wouldn't give you an answer that is here. That means that we're probably going to take a different approach.
Sir, what if you change the 24 dm cube to another unit?
To another unit, to what unit do you propose?
The other one,
STP?
Yeah.
Why would you want to do that? Just ask it.
Sir, I don't know how to answer that question. I'm just trying to figure out a way to answer the question.
Okay. But no, not generally. The mass of lead oxide which can be obtained from that much grams of lead nitrate. So, alright, so I completed this question previously. Right, so I want you guys to probably have a look at it. Have a look at it and send the answers in the group that you get. And then we'll see what would be the best approach to it. We're gonna come back to this. In the interest of time, we're gonna come back to this. Right? Which are the following components of a giant molecular structure here?
B.
Silicon. What is the answer for this? If 86 grams of ionic salt that is heated. Okay, what would be the answer for this? Number 10? Right? It's heated so that all the water crystallization is driven off, and 68.0 grams of calcium sulfate remains. The value of X is. You guys can go and figure it out.
So without D,
B. All right. So everybody else agrees.
Yes, sir.
Okay. So we're saying that B is the best answer here. So I hope everybody knows how to get this. I also provided an explanation to this. I think it was 2021 people did all the explanations on it. So you guys can look at that. Give me one moment. Let me just address somebody real quick. My apologies. Alright, so we're saying that B would be the best answer here. Yeah, 13.2 grams. That's interesting. Okay, so let's look at this. 11, the overall balance equation, well, chemical equation for this reaction would be what? This is a repeat, right? What's the answer? Cancel out the electrons. Or D.
D.
The oxidizing agent, can somebody remind me of it?
B,
B. Alright. Sodium can form ionic bonds with each of the halides, right? The sodium halide is expected to have the highest lattice energy, would be
B,
B. We saw this already as well. This one, no. What would be the answer here? I'm letting this person. What would be the answer here? So it's gonna be 822. This would be plus negative 10, 11. Ooh, right? So 110. What would be the answer to this?
D.
D. Wonderful. We know why this is positive, right? Because this is forward, and in the question here we have it in reverse. Therefore, we should change the value to positive. Alright. So, which of the following gases is closest to behaving? Okay, we'll saw this already. Which of the following phases describes the activation energy of the requirement of the reaction? So this would be the energy barrier to the reaction. And if we're going to be reacting hydrochloric acid with calcium carbonate here, we're going to be removing carbon dioxide, right? Carbon dioxide would be evolved, and we're going to use a gas syringe experiment, and that is how it's set up, B. Alright, so let's move on. Let's look at this now. So the rate of reaction here is that, obviously. Which of the following best illustrates the slow step? Right, so the slow step here would have been, why are you connecting hydrogen right there? That shouldn't be, right? Alright, what would be the slow step here? Is the slow step even here? I mean, technically. Let me just check something for a second. Give me one moment, guys. No, that's wrong. And then
So
that's
be
not
A.
wrong. Oh, go ahead. Why would it be
Would
A?
be because the slow steps here, it's showing the double bond there and the 3 right there, and so when it gets that's in the reactant stage is showing the 3 of the hydrogen and with a hydrogen, yeah. And yeah.
Okay, hold on. Right, the reaction here. Hold on. Let me show this. Let me let in this person take into the thing. So the reaction here has here we have acetone along with iodine, and here we have iodo. This would be an iodo alcohol, alright? Here. So shouldn't technically be, but let me draw the structure. C2I. The I should be right there. CO. Alright. Okay, I'm seeing that. Alright, so we should have that as well with adding these. Within this one though, what I'm seeing, right, is that this is being added, which is not supposed to be here. And this is being added here, which is technically not supposed. Well, hold on, let me remove that. So the acid, specifically species, would be removed. So I want to look at that first. So it should be like an intermediate step in a sense, right? So the slow step is usually the formation of the carbon. Wait, hold on. Is this unit 1? This is unit 1, isn't it? This is unit 2 content. Really simple unit 2 content, may I add. Yeah, so this is gonna be, should I skip this question or still do it?
Still do it, sir.
I'm trying to figure out whether or not. Okay. Still do it. Okay. So let's look at this. The acetone plus the iodine. What we're going to have is carbocation forming iodine forming 222. This would be here, then here. Technically, releasing that as an electron. Well, as a nucleophile. All right. I don't understand where the oxygen is going though. It should create a hydro. It should create this. This is the answer. So I think that this should be the best answer, I guess. Probably it should create that. Based off what is happening. But the slow step technically would just be that. It won't remove oxygen. Alright, hold on. Give me one moment again. Let me just check this one then. I'm wondering, you guys have any idea what's happening though? This would be negative. Hydrogen will attach there. This would create a carbocation because it will now be flat. And then iodine would, okay. I have a feeling that A would be the better answer to put here. Okay, let me erase all of this. I have a feeling that A would be the better answer for real. But this is no longer on your syllabus, I believe. I don't think it's on your syllabus anymore. Alright, so there's A. But you guys should have known this already, to be very honest. It is technically in your syllabus, so it should be fine. Alright, 20, well, number 19, which are the following statements, does not refer to a system in dynamic equilibrium. What's the answer? Concentration
C.
to okay, reactants and production is equal. It's constantly changing technically. It appears equal, but I don't think they are equal. The rate of forward and rate of backward is equal, not technically, but oh, go ahead. Somebody saying something? Let me check the chat real quick. Okay, somebody was saying C. Okay, here now we saw this to be this already. Let's move on. Okay. The maximum yield of ammonia obtained would be what? So it is an exothermic reaction, therefore we're going to need a low temperature and it's going to gases favor the high. Okay, so we're gonna have C. You guys understand this?
Yeah.
Everybody understands it?
Yes, sir.
Alright. So conjugate acid and conjugate base aligned correctly.
Someone was asking what was 20.
What was 20? 20C. 430, a repeated question. Alright, let's just scroll down and look at this now. So the pairs of acids and conjugate bases correctly aligned. This is foolishness. This is foolishness also. And this is rubbish. So C would be the best answer. And then down here is 3.9 as it repeated. Right. Let's look at 20. What this is 20 something, 25. Which of the following pairs of substances would make a good buffer? Strong acid can't use that. Our base and its salt, that should be fine. The solubility of product of barium here at that, okay, right, is that right? The number of moles of barium sulfate that will be dissolved in 1 dm³ of water to form a saturated solution is 1. Right, so it's going to be square root of that, and you're supposed to get 1 times what, 10 to the negative. Okay, you're supposed to get 1. Is it that, or I should change? If you square root 1 times 10 to the negative 10, what do you get? You get 5, right? 1 to the power 1 times 10 to the negative 5th power, right? C. Which of the following expressions represents the solubility product of iron hydroxide? Right? So we're gonna have this. Which of the following, oh sorry, what is the potential for the cell reaction here? We saw this as well. Moving on. Everybody's fine so far?
Yes, sir.
This repeated. Alright, so that would be that answer. Which of the following situations does not occur in the cell shown here? So what doesn't occur? No current flows from the salt, well, when the salt bridge is removed. That's not true. So that's not true. Magnesium ions migrate to the salt bridge. Magnesium ions? Magnesium ions? Yeah, that's not supposed to be happening. Right? That's not supposed to be happening. So let's move on. Magnesium ions, no. Right? The ions of the half shell should not be moving to the salt bridge or whatsoever. Right? So generally, let's check everything else to make sure that it makes sense. You're guys gonna have to use the data booklet to do this. Alright, but it should be losing electrons there, so it should be fine. There are 8 elements of the 3rd period, right? Sodium to argon. Which of these elements exists as a diatomic molecule? Which one would it be? Sulfur?
Chlorine.
Okay, chlorine. An element in period 3 combines with oxygen to form an oxide which reacts with water to produce a strong alkali. The answer is period 3.
D, sodium.
Sodium, wonderful. Which of the following elements in the 3rd period has the same oxidation number in all of its known compounds?
Aluminum.
Sure? Aluminium is the answer. We agree?
Yes, sir. Aluminum.
Okay. The aluminium. Okay, so I think the answer should be chlorine. Why do you think aluminium? Aluminium hydride is -3 for aluminium. Aluminium oxide is -2 for aluminium. Aluminium chloride is -1 for aluminium. So we can't have the oxidation state being the same for all of them. That's not true, right? The general rule for it will change. Well, it will change, right? Chlorine though, what happened to chlorine? Chlorine can have an oxidation state of +1, right? If you put it in the chloride ion. Not true. Is ions we're looking for are compounds generally. It says compounds, right? Chlorine will have the -1 oxidation state in its compounds, no. You commonly exhibit that. But they may change. What would be the answer? Okay, everybody agreed with aluminum as the first one though. I'm not sure about that, Because now that I'm thinking about it, sulfur would have tons of oxidation state. And then phosphorus. Is phosphorus the answer? If you think about phosphorus, phosphorus have many oxidation states as well. We're looking at the third period, same oxidation state number in all of its known compounds. So which one are we going with? Aluminium or chlorine? The thing is technically all of them generally yeah, the thing is technically all of them generally have different oxidation states, right? Most elements
Chlorine
do.
most likely.
Yeah, but yeah, chlorine most likely. In its compounds. In ions, complex ions, chlorine will change, but generally within its compounds that we use, it would just be -1. 34 calcium. Okay, we'll look at this as well. Right, which are the following statements about oxides of the elements in period 3, sodium to chlorine, is not true? I think B is the answer. Because it's not true for all the oxides. It's not all of them. Remember C. Look at C. The oxidation number of the element, right, in the of the element in the oxides increases across the period, technically, right? Across the period, the oxides change from basic to amphoteric to acidic, right? So all the oxides won't provide alkaline solutions. Some will provide acidic solution, etc. So B would be the answer. 36, which of the following properties belong to group 2 elements? What did we say? D?
D.
Alright. The insolubilities of group 2 sulfates make them very useful in diagnostic medicine because they appear opaque in X-rays. Which sulfate is most commonly used for X-rays?
Yeah.
Barium sulfate, wonderful. Right. Which of the following statements about bromine is correct? Red bound color, denser than chlorine, gas at room temperature and pressure. Sure. It should be a volatile liquid, but more or less sure. It's supposed to be a volatile liquid. Do you guys go with 3 as an answer? Even though technically it's a liquid, so A, right? So volatile liquid, so it would exist as both gas and liquid, but most times we refer to it as a liquid. So it's because of its volatility. Because for example, alcohol always exhibits, well, to be very honest, almost literally every single substance that have something about it, right? It can exist as both at the same state, so it should be fine. 39. Which of the following complexes will show the greatest paramagnetic property? What the answer here? I'm waiting. Would be Fe2 plus, right? And where would Fe be 2 plus here? Where would iron be 2 plus here?
Sure, C.
C, sure. Everybody else? C is the answer. Sure.
No, B or C.
Or it's B or C, but okay. Well, it should be iron though, so what would be the answer, B or C?
B.
B. Alright. You see, give me one moment. Hello? What did you say? Alright, I'm back. So B, let's look at this. That will be 6 there. Okay. That will be 10. Alright. So that should be fine. Copper 2 sulfate gives those. Which of the following deductions can be made from these observations? So a deep blue solution is made in excess ammonia, so we're gonna have the complex ion being formed. Yellow-green solution with excess hydrogen chloride. Well, the hydrogen chloride. We're gonna have this being no. So 1 and 2, right? Fine?
Yes, sir.
Alright,
Yes.
wonderful. So, which of the following statements describe the trend in physical properties of the halogens? Physical properties, not chemical properties. So, what are the physical properties? Alright, we're speaking to this. Right? Which of the following options are the halide ions placed in order of increasing or reducing power? What is the answer?
C.
Okay. Everybody else agrees? When you put the halides in order of reducing power, so fluorine will be the highest, then chlorine, then bromine, then iodine. So it should be chlorine, bromine, then iodine. C. 43. Which of the following solutions is best suited to determine the presence of halides in river water? Silver nitrate, right?
Yes, sir. Silver nitrate.
Wonderful. Alright, the next thing now, which of the following options correctly identifies the ions which may be present in each of the following solutions? So 1, a white, okay, wait, hold on. So aqueous barium chloride following a dilute HCl is added to each of the 4 unknown solutions. So barium chloride, I mean, okay, sure. Okay. So we're gonna have that there. So the white precipitate is formed, which dissolves in the acid and to liberate gas, which decolorizes acidified potassium permanganate, or acidified but permanganate? What will be the answer for that? So that would be what? Okay. So let's verify them. 4 says a white precipitate is formed which dissolves in the acid to liberate gas, which forms a white precipitate, right? So all of these are right. These are right. A dense white precipitate is formed which is insoluble in excess acid. Which one of these would be right? We had HCl, you know. No precipitate was formed. Come on, guys, what's the answer?
SO4.
SO4 for what? 3?
Yeah.
So if it's SO4, then that means that D is the answer?
Yeah.
Okay, so you're saying that SO4 would form the precipitate that is insoluble in excess, right? Okay. Everyone else agrees? I don't think you guys get any of these questions anymore, you know. I'm not sure. Which of the following reagents does not aid in the identification of X? Nitric acid, right? Nitric acid. So we have that there. For the question that we were doing above, where is the question? It wasn't this. It was this, right? This question. Did anybody figure out a way to do it? No?
So you'd have to find a number of moles, I guess, to do it. Not sure.
Alright, so here though, let's get an idea of what should happen here. It's a small idea. If we're looking at this, what could I say about this? How would I explain this? Okay, so we're saying that the mass of the lead, right? The mass of the lead nitrate, right, would be 207. 207. Let me recalculate. 207 point something, right? 207. Yes, that one. .2 grams per mole, right? So we have that there. Fine. Fine, guys. Wait, so it's gonna be 207.2 times. Okay, so it's gonna be 331. Okay, so sorry about that. The mass would be 331.22, I think. So it would be that would be grams per mole, right? So the molar mass, right? So the molar mass of this per mole would be 331.22, I believe, right? So that would be it. So the number of moles now would be that divided by what we had there. So we're gonna have 331.22 as we stated here, divided by the 13.23. I was supposed to get 0.00. No, 0.399. I'm supposed to get that. Right? What do we do after we reach there now? Right? So since the molar ratio is 1:1, the number of moles of the lead oxide produced will be the same number of moles of the lead nitrate. Now so So the mass of the lead oxide would be 207.2. So the mass of that would be 207.2. We're looking at that, right? That would be the molar mass there. And now the
Yes.
mass of the oxide, right, would be the number of moles times the molar mass, which would be that times the molar mass, 0.399. I think that somebody got it a while ago, you know.
The answer, sir. I was just-
8.27 grams. So what would be the answer?
Sir, C. C.
See? But I got 8.27, so
No, sir. The molar mass for lead oxide is 223.
223. Oh, I'm getting it wrong. 223. Alright, so my molar mass is wrong. So if it was 223, you should get the 8.91.
I got 8.89.
8.8, which is fine. Hold on. The screen went black. Wait, so 223 you said. So that should be 8.89. So let's see the answer. Alright. So everybody's fine with that though? Everybody's good? Alright, so that would be the end of that paper.